Trapezium rule is a topic that we are going to handle. This is now for this falls under numerical methods. And we say in numerical methods you expect two questions in section A and also in section B. So one of the questions you can find is the trapezium rule, the way how to use the trapezium. So this is an approximate method. Use estimate and integral or the area under a curve. Use the estimate and integral or the area and the curve. I think in now here we have seen the area and the curve. And the curve from an interval from A to B, provided that if you don't write it like this, we can already write it. This means that it's from A up to B, rosy. Provided that the function is continuous on that interval. This interval continuous means it's defined. You can't find it when it's undefined on that interval. Consider the function f of x continuous on A, and this means from A to B. This is the same as this. The area, we will not get the area of a function. This from A to B we just interpret. Can be estimated as shown below. So now, if we plot this function here as our f of x, I think you see, now we try to divide it into some strips. So, if I divide it into these small strips like this, like I'm doing, here I'm stripping because there are some now. Assuming that from here up to here, it's having a width of h, and this x0 corresponds to y0, x1, like that. Then, it means that now, this one here is what we call a sub-interval or a strip. Then, these vertical lines, these ones, are always called ordinates. There is a difference between strips and ordinates. The vertical lines are what we call, so if I have this vertical line and this one, I have 3 ordinates. But here, there are 2 strips. There are 3 ordinates. These vertical lines are called ordinates, but there are 2 strips or sub-intervals. That's the difference. Always, ordinates are more compared to the number of strips. So for n sub-intervals, now these n sub-intervals here. So we are going to say, we know now these ones are looking as trapeziums. I think we see the shape. And we say the area of the trapezium is given by a equal to a half h times the sum of the longer sides. Now, after doing this, and now we are coming on A. A is the first strip here. To get A, remember from here up to here, the height is h. That's why you have h. Then from here up to here, it's going to be y0. Then from here up to here, it's going to be y1. That's why I'm having it there. Now when I come strip 2, from here up to here, this strip 2 has the straight side, this has the long side. This from here up to here is y1, yet from here up to here is y2. That's why it's then we multiply with h. These ones are having the same width. Now, when I come to the last one, remember this one is, when I'm studying this one here. So, the height is the same, the width. Then from here up to here, the size from here up to here is the corresponding value of y, which is n, yn minus 1. Then this one up to here is yn. So it's that we are skipping some, but they are in there. We are assuming that this one, they are in there. But now, we are using an approximate, because this is an approximation, there is an approximation side, because this area is always an approximate. Why? Because it's that some of these things are going to be missing out, these sides, they are going to be missing out of that area. So that's why we're using some approximation there. Now, you see, if I pull out, after some stripping in, if I pull, now here it means that this one is going to be yn minus 2, then plus yn minus 1. So, if I pull out this half, because a half h is common, if I pull it out, I mean this here, now this and this is going to be, see that always the b of the last is going to be the a of the next. The b of the last is going to be the a of the next, like that. So, meaning, if this is our b of the last, Then this one is going to be its A. Then this A is going to be now the B of the next strip of the previous strip. Then it will be having also that. Okay, so if I try to summarize it like that, now it's that this y naught and yn, they are the ones which are not similar. But it's that always y1 and y1 they are going to be 2 times, y2 and y2 also 2 times, and also yn minus 1 they are going to be 2. So if we factorize out these two, we bring these and which are not together, which are not doubled, we have now these two out, we have this, then plus, up when we reach the n minus 1 vertical or ordinate. So, this is what we call the trapezium rule, but don't forget, it's an approximate of that area, an approximation of that area, where x naught is the first x coordinate up to xn, which is our b. So to get this height here, we get the difference from this one, the difference from xc. This one we get if this is x1, our b is xcn. Okay, xn. So to get the difference between our heights, we shall get just, you get this minus this, the one minus the one below. So that's how we get our height. Then we divide by the number of strips. So we get this minus this, then divide by the number of strips we are having. That's how we are going to get our height. This is always a constant because the secret is just, it's not variable in anything. Now, y naught, y1, y2, up to n are the ones we call ordinates. If you don't call them coordinates, we call them verticals. If we have n coordinates, then we have n minus 1 strips. So we say in orange, look at this. You start here, in orange, the verticals are 1, 2, 3. But there we have 2 strips. This is the strip and this is the strip. So that orange coordinates are more by 1 compared to the strips. That's why if I have n, then the strips are n minus 1. If we have 3, then the strips are 2. n3 minus 1, which is a 2. So this is always not if the PV coordinates, then we get n minus 1 strips. Then let us see this note. The value of A obtained is an approximation or an approximate value. Why? Because we have seen that some they are not going to be covered. So to reduce, so we expect an error there because this is an approximation. So to get it, we expect an error in there. Error means that there is something that is not giving the exact value. To reduce on the error, we always have to increase on the number of strips or the number. Now, if we make these ones smaller in size, even the error is going to reduce. So the smaller the strips, the more exact the value is. So when approximating the area for trigonometry, so this is what it's all about. So if they tell you how can you reduce on the error or how do we make the value more exact, you just tell them you increase on the number of strips or the number of sub-intervals or ordinates, the same. So if you increase those ordinates, remember the more ordinates you have, the more strips you have. So that's what it means. When approximating area for three functions, the calculator should always be put in radians mode. Radians, I think you know what it is. So the error is always given by the exact minus the approximate. This is how we get the error. We get the absolute value. This means we get the absolute value. Then the percentage error is always given by the error over the exact, but we've seen the error is something like this. Then it's 100. Now, to find the exact values of integrals, we always interpret them using integration techniques or the calculus, meaning that this topic, to handle this topic, you have to be having some ideas of integration. Because we are going to see, we are going to integrate sine functions, natural logarithms, exponential functions, and so on. So, to cover this, you have an idea about integration. Now, why do we use trapezium rule? We use it because there are some hard to integrate functions which we can't integrate in some cases using calculus. So we can, but they are tedious. So that's why we employ trapezium, because we can get that approximate value to those integrals. So the reason why we use this is that to simplify some equations which are hard to integrate. Like when you try to integrate sine x over x dx, that one is hard to integrate using calculus, but you can easily get this approximate value using the trapezium rule. So let us see examples in the next lesson. Don't forget to subscribe to the channel. Wish you well.